Uh, well, Accord as a company, we are a 30-year-old company, and the session here, it's called Design for India and for India, right? So I need to squeeze the 30-year journey into maybe 5, 6 minutes. So that's a hard task. So before I enter into the journey, the 30-year journey of Accord as a GNSS company, I would just like to give a brief about what this company is all about. So we are a Bangalore-based company in existence for 32 years now. Our core technology focus has been on GNSS since inception. So it is the R&D, the research development, the manufacturing aspects, everything has been focused or centered around GNSS as a core. So I'm not sure. I think Mr. Sanjeev introduced the concept of GPS, which a lot of you here, I'm sure all of you know. But you can see a term GNSS here. Is it something which is familiar as well? I mean, how many of you know GNSS as a terminology? Okay, very few. So let me introduce you to GNSS. So before this, I think this is just a testimonial to all the research and development that has gone in. And over the course of the slides, I'll be able to tell you more about where our technology has been deployed. So GNSS as a terminology is a amalgamation of lot of satellite-based technologies which have been launched by different countries. I think earlier in the session today, there was a talk about geopolitical issues which is prompting India and a lot of other countries to invest in indigenous technologies, right? So when we started off, this was about 30 years back. So back then, GPS was the only viable means of satellite-based navigation. Now, what is GPS? So a lot of people confuse GPS with what they see on the phone, right? But GPS is a much bigger and complicated system. It has three essential elements. So there is a space segment which consists of a lot of satellites. If I speak about GPS, there are close to around 30 satellites, about 20,000 kilometers from the surface of the Earth, orbiting, sending some data continuously to the Earth. Then you have the control segment situated on the ground, which continuously monitors, does the data uploads to these satellites. And finally, the largest community is the user community, right? So all of us as consumers of that data fall into this segment. So GPS being one of the foremost satellite-based navigation technologies was sent into space by Department of Defense in US. So as you can see, this technology arose out of a defense need. It was not conceived as a commercial need. But later on, the commercial use cases picked up so much that today, I think excess of 80 or 85% of use cases belong in the commercial category. Of course, the defense segments are also predominantly using this technology, but it's the consumer space that is driving this technology, so much so that today this signal is free for use. I mean, there is no charge for you to use the signals which are being beamed from these satellites. Now, GPS was first, and this was during the Cold War days. So Russia, back then it was Soviet Union, they were not to be left behind. So they came up with their own satellite-based system called the GLONASS. So it is still functional today, but it went through a lot of upheavals during the disintegration of Soviet Union, becoming Russia, and Russia did not have a lot of facilities to support this program. But now they have put in a lot of investment. They are launching additional satellites. So GLONASS is now a viable alternative to GPS. The European Union wanted to come up with its own system, again, for geopolitical reasons. So today, Galileo as a satellite-based navigation system is also in existence. So satellites are beaming down signals all around the Earth, right? China also came into existence, and they actually overtook. In fact, Galileo was conceived in the early 2000s, and they were operational only in 2016. Whereas China came up later, but they were much quicker to launch their satellites, and today they have their complete set of constellation. Their third generation is available in the space today. Then of course, India was not to be left behind. So ISRO put in the efforts. So in 2016, we had our first full constellation. It was earlier called as IRNSS, if some of you can remember that terminology. But it was later coined as NAVIC, navigation using Indian constellation. And QZSS is another constellation which has been launched by Japan. So today, if you see, there are many such systems, excess of 100 satellites beaming the signals down to the Earth, right? Of them, the first 4 are global systems. That is, anywhere you go, you will get the signals from these constellations, whereas NAVIC and QZSS are regional systems. That is, NAVIC is concentrated on the Indian subcontinent, maybe extending around 1,500 kilometers on either side of our landmass. QZSS is again focused on Japan, right? Now, what do we need on the ground in order to receive these signals and make sense of it? So we have what are known as GNSS receivers, because we only require receiving. We don't require anything that we need to transmit back to the satellites. So we only need to receive these signals, decode them, make some sense of it, and provide some useful data. And what is that useful data? It is P and T, right? Position, navigation, and time. So these are the 3 primary outputs of any GNSS receiver. So just one slide on NAVIC. I'll not spend a lot of time on it. So it consists of a full constellation of 7 satellites, which are in the geostationary and geosynchronous satellites. So they continuously beam the signals in 2 frequency bands. One is at 1.1 gigahertz, the other is in S band, right? And ISRO is also working towards upgrading the signal structure to a L1 band, which is at 1.5 gigahertz. So going to what we did, see, as a 30-year-old company, what did we do? So back then, when we started, the founders took a call that, okay, let us invest in something new, which was not available in India at that time. So they focused and narrowed down on GPS. So in fact, on a lighter note, when I talked to them recently, asking them, why did you choose this? I mean, those were the days when the Infosys and other companies were also coming into place, and they were focusing more on the services segment, right? So why did you get into this product design, knowing all well that this is a very complicated piece of technology? Not much of literature was available. I mean, today you can Google it and get the information in a matter of seconds. But back then we had to get the documentation from US by post. So that was the kind of difficulties we had to even get information about GPS. So they said, so we heard about this technology, okay, and we know that it's going to be big in the automotive segment, because location was something that they had foreseen. It would be prevalent, and a lot of use cases would arise due to location, right? And they just saw the rainbow, pot of gold at the end of the rainbow, and said, yes, let's do it. But the same thing, if they had to decide today, they would not do it. So that's the kind of technology complexity that was back in the early 90s. So we started off by creating something out of available components. So the entire architecture was conceived around software back then. So we used commercial off-the-shelf DSPs, standard front ends, and wrote the entire signal processing algorithm in software. So this was one of the world's first software-based GPS. And later, I think there was a question in one of the earlier sessions that there is going to be, what is the need of a custom chip? So this basically was the need, because commercial off-the-shelf parts may not fully serve your requirements. So we need to go custom, design something as per our requirements. So that led us into the silicon journey, and we started this in the early 2000s, and today we have 3rd generation silicon available with us. So just have it just to show you. Okay. So using this, so this is the entire portfolio that we have today on the GNSS spectrum. So we are focused only on GNSS. So we have our IPs. We use that to fabricate silicon of multiple hues. We use them to build modules, and we also develop end systems using these. So these systems have gone in, I'll just skip these because this is basically talking about the latest chips that I have in my hand today. So this is architecture. I'll not get into a lot of details. Yeah, this is the modules. So I'll just get to the last one of the last slides here in terms of applications. So what did we use this for? So in fact, our first commercial use case for our software-based GPS happened with ISRO. So from 1999 till recently, all the PSLV satellite launches as well as the satellites carried our receivers. Then, following the success there, DRDO, one of the labs in DRDO, RCI, they came and they were quite interested in indigenizing this technology. And today, almost all our strategic weapons carry our technology. So we are basically safeguarding our nation through the use of an indigenously developed technology. And of course, today the technology is now predominantly NAVIC based because it's an Indian system. So yeah, I would like to end it.